Alright, so now I'm going to go into a couple things. First of all, a lot of people had trouble with removing a particular object from an array, or not necessarily an array, but just removing a particular object, and a lot of people had problems with debugging. So we're going to go through both of those problems right now. The method we're going to write is going to be called public void cell product p, where the user passes in a product they want to remove. Product to remove, and that exact product is removed. Alright, so to do this, what we need to do is first we need to figure out if the problem is in our array. So for this, and we need to figure out where it is. Like we need to know if our product is there, and if it's in our, like if it's there, where it is. So we can say int, we can say integer location is there. So now we can say for int I equals 0, I is less than inventory dot length, I plus plus. And then we can say if inventory I dot equals p, location equals I. And that's that. Now we can just say if location, or if location is not null, equals null. So if location is not null, we can say for I equals 0. Now we're iterating through, or we'll need to create first a temporary array, just like before. So we can say product temp is equal to new product, and then here we'll put inventory.length minus 1, because it's going to be removed. So now we can say for it I is equals 0, I is less than inventory.length, because we still want to read our whole inventory, I plus plus. And now we can say if I is equal to location.value. If I is the location, then we can say nothing, or we can say if I is not the location. We will say if I is less than the location, inventory, or temp I is equal to inventory I, and then else temp I minus 1 is equal to inventory I. So this way we end up essentially skipping over the index of our removed item. And at the end of this whole loop, we can say inventory equals temp. Should be a pretty solid method, right? Well, we can't be too sure. Let's try to run it. And we'll put our data in, and it does nothing. But so how do we test it? Well, let's create a bit of a tester for us. So we'll create a new class. We're going to call it removal tester. It's going to have a main method. Void main string. The main is lowercase. Main string args. And in here we're going to put, let's say, cartel c equals new cartel. And now we're going to create a few products. So product p equals new pizza. Gary. We're going to say product p is equal to new pizza. Yeah. And then let's say product f is equal to legal pizza. And product g is equal to new pizza. Like such. And all different products. So now we say, let's create a user. So client user is client. And we give it a name. And not a name. So now we say user.by p user.by p. And let's go to the so we're just going to catch. No, come on. And this is user.by by f. User.by p. Alright, so now this is kind of our tester. We've got a bunch of different products. So now we can try selling them. So we can try user.sell, say f because it's in the middle, user.sell p because it's at the start, user.sell g because it's at the end, and user.sell v because it's the last one to make. And now edge cases will include edge cases include things at the end, things at the start, usually things in the middle. Just try everything. Alright, so now let's run this with breakpoints and let's see what it does. We'll say, where did I put this? Self-product with breakpoints, and we'll watch what our method does, and we're going to see if it's doing the right thing. We also put statements, and we should put statements in the debugger. We'll run it with a debugger. So right now we have a inventory which has 4 products in it: pizza at 859, pizza at 860, illegal pizza at 803, and pizza at 861. We want to remove illegal pizza at 803, so we go through. First one is not the right one, second one is not the right one. Third one is the right one, so the location is 2. Go through. Oh, location is 3. Why is that? Well, I think what happens is our equals method compares the name, right? But it doesn't compare, or it compares the legality if it's called on a product. Now, since illegal pizza never actually replaces equals, we can see that there's an error, not even in the method that we wrote, but there's an error in a different method which we discovered through writing this. We can see that the equals method of illegal pizza only compares, well, it actually doesn't compare anything. If we go into our product equals, it doesn't do much. It just says, well, it says return is legal for this one is equal to product is legal for the other one, and product equals product. Oh, what the heck? Okay, so it's just like a bit of a nonsense method, but clearly it's not comparing the right things here. Pizza is, oh yes, this is where it's comparing the right thing. And then alright, so now we can rerun this and we can see if this actually works properly. So we run through this again, we look through, I equals 2, location is set to 2. Okay, now the equals methods work properly, and the location of what we want to remove is 2. Let's just verify that. It is, in fact, the correct location. So we got the first part of our method right. Now let's go through and see. So I is not the location. It's true. So I is less than the location. It's true. It's just going to copy it directly. Now it's going to do that again. It's going to copy it directly. So now our temp contains 0 and 1, which are the exact same as 0 and 1 from inventory. Now we go into here, and we see that this one is skipped. It just skips I equals 2 entirely. Goes straight to I equals 3, goes into here, and it says temp I minus 1 is equal to inventory I, so it's pizza at 870, and we can see that we did indeed correctly remove that illegal pizza, updated our inventory. Now we go into here again, we want to remove pizza at 860, that's the first pizza in the list, I equals 0, and location equals 0, our location updated correctly. We go through here, we're just skipping 0, going into here, starting the copy, looking into our temp, we see that 0 is the second element of the original inventory. And now our inventory has this. Now we have 2 items left in inventory. We're just going to remove the last one. I equals 1. Go into here, see. Okay, now our inventory just has one thing. Will it break with just one thing in the inventory? It appears that it will not break. So indeed, we have successfully created and debugged a method which will remove an object from our inventory. We've made sure it works with all cases. So that is when the inventory is empty, when it has just one item, when what we're removing is at the end, we're removing at the start. Basically, we've gone through conclusively and created a great method that will help us remove things from our inventory. It took some debugging, of course, but we learned in the process how to use the breakpoint debugger and how to remove something from the middle of an array. And then similar principles apply in basically any data structure. This general algorithm for removal is pretty common. It can be made faster. You don't have to actually loop through it twice. You can make it better by making it loop through just once and doing this comparison in here. But that is an exercise which I can leave to you guys. Awesome. Well, hope you enjoyed, and good luck on your debugging. Yeah, so we can make this more efficient, just saying. So if you guys want to challenge yourselves a little bit, you can make a better version of this algorithm where instead of checking if the item is correct here, you actually check it in this loop. Good luck. We'll rerun this with just a regular run, no debugger. If we have breakpoints, it doesn't have to stop there. We can just run it like this. So now it's sorting by which color is the most red to the least red.